Howdy. All right. AP Calc final exam review video number 2. On this video, we're going to start on page 121 here at number 28, and I'm going to go to page 130 and go through number 64. So we're covering a lot of problems in this video, but it's just a little bit. We're still going to be in derivatives. I went ahead and wrote down the trig derivatives, and you will want this on your cheat sheet if you're using a cheat sheet. Otherwise, you gotta just completely memorize it. So pause the video, make sure you write those down. If you're already making your cheat sheet, make some space for that. Turn to page 121, and let's start at number 28. So it says, and we're supposed to take the derivatives. All we're going to be doing is taking the derivatives this video. So f of theta is theta plus 1 times cosine theta. This is product rule. You got two things to multiply out here. So f prime of theta. The first, theta plus 1, times the derivative of cosine theta. So that's times negative sine theta. I put a little times there so I don't accidentally subtract it when I put it all together. Plus the second, cosine theta, times the derivative of theta plus 1, which is just 1. So watch me not write it. All right, so that's going to be minus sine, and that's supposed to be a theta plus 1, sorry. Minus sine theta times theta plus 1. All right, you know, it would be better to put the theta plus 1 out front so you don't confuse it with the angle. So sorry about that. I'd probably write this as minus theta plus 1 sine theta plus cosine theta. Probably the best way to write it. But it'd be okay if you did it the other way. All right, next one on the list is number 30. And number 30, we have f of x is equal to sine x over x. Quotient rule. So f prime of x, the bottom, x times the derivative of the top, that's cosine x, minus the top, sine x, times the derivative of the bottom, that's 1. I won't write it. All over the bottom squared. Okay, that is it. Don't try to do anything further with that, and you are good to go. Let's try 32. We have y is equal to x plus cotangent x. So y prime would be derivative of x is 1. Don't forget and take the antiderivative, make that 1/2 x squared. You got to remember what you're doing here. Derivative of cotangent is minus cosecant, so minus cosecant squared x. I believe there's an identity where we could call that something else like cotangent squared x, but don't worry about that. This is fine with me. All right, the next one is number 36. So number 36, we have y is equal to secant x over x. So this is the quotient rule. The bottom, x, times the derivative of secant, which is secant x tangent x, bottom times derivative of the top, minus the top secant x, times the derivative of the bottom, that would just be 1, all over the bottom squared. The book would probably factor out a secant x. I don't see the point of that, so this is fine. I don't think it doesn't make it where you can cancel anything out, so it's really not a lot better. Let's see if we can squeeze in number 40 here. F of x is sine x times cosine x. So f prime of x is the first, sine x, times the derivative of cosine x, so times negative sine x, plus the second, cosine x, times the derivative of the first, cosine x. So that would be minus sine squared x plus cosine squared x. I do expect you to do at least a little bit of simplification instead of just leaving it like that. So don't be lazy. That's a pretty easy simplification to do. Let me squeeze in number 42 here and then I'll erase. So with 42 we have h of theta is equal to 5 secant theta plus tangent theta. All right, h prime of theta, the derivative of secant theta would be secant tangent, so that's 5 secant theta tangent theta plus secant squared theta. All right. The book also probably would factor out a secant theta, but to me it doesn't really make anything better if you do that. It doesn't really make it a tremendously simpler function, whereas here you're getting rid of, you know, if by combining and making it squared, you're getting rid of two terms, so I think that's worth it. All right, I'm going to erase, so pause if you need to, and we will pick up with number 48. All right, we have f of x is equal to tangent x cotangent x. This one's pretty interesting because you could go through the product rule and do all that, but if you can just rewrite this, f of x, think about it, what is tangent times cotangent? It's tangent x times 1 over tangent x. Well, that's just 1. So if f of x is 1, f prime of x is just 0. All right, so I just wanted to throw that in case you get something, you know, pretty, you don't want to do a lot of work you don't have to there. Okay, that gets that section done. Let's go on to the chain rule. So turn over to page 130. And I'll try to remind you how to do the chain rule. All right, and we are starting with number 8 on page 130. So we have y is equal to 3x squared plus 1 to the 4th. So y prime, we're going to bring that 4 out front. 4 times 3x squared plus 1. Subtract 1 from the exponent, so 3. Do not forget the derivative of the block. It's so easy to forget, and so many students do it. So times 6x. I do expect you to consolidate this a little bit. So I'd have 24x times 3x squared plus 1 cubed. All right. Great, let's do number 12. So number 12, f of t is equal to 9t plus 2 to the 2/3 power. All right, it may be written in the book, cube root of 9t plus 2 squared. I'm not sure, I don't have the book open right now, but you're going to want to put it in fractional exponent form if it's not. So f prime of t is equal to 2/3 times 9t plus 2 to the 2/3 minus 1 would be minus 1/3, and then don't forget times the derivative of the block, so that's going to be times 9. I do expect you to get rid of the negative exponent, so that's going to be 18, right, times 9t plus 2 to the 1/3 over 3, and then 18 over 3 is, so you could just make that 6 times 9t plus 2 to the 1/3. I do expect you to at least do that much. Excuse me, I'm sorry. I need to bring this down underneath, so I apologize for wasting your time there. Probably you were screaming at the device you were watching it on, right? This is going to be 18. 2 times 9, 18 over 3 times 9t plus 2 to the 1/3. So we had to bring that negative 1/3 down. So apologize for that. So that'd be 6 over 9t plus 2 to the 1/3. All right, if you had to erase, sorry about that. And you can make that a cube root with a radical if you want. Okay, let's, I'm going to erase, so because 18 is going to take me a little space. All right, 18, we have f of x, and it is negative 3 times 2 minus 9x to the 1/4. Okay, in the book it may have the 4th root of this, but this is how you want to rewrite it. If f prime of x, 1/4 times negative 3 would be negative 3/4 times 2 minus 9x to the 1/4 minus 4/4 would be negative 3/4 times the derivative of the block, negative 9. So negative 9 times negative 3 would be 27. Then we have the 4 on bottom, and let's bring that 2 minus 9x to the negative 3/4 downstairs. So 2 minus 9x to the 3/4. And I think that's about as good as we're going to be able to do on that one. 22. We have y is equal to negative 4 over t plus 2 squared. So let's rewrite this one as y is equal to negative 4. You can do this. You could do that as a quotient rule. But we can probably, it's probably a little easier if we rewrite it like this. And then we can make it just a product rule. All right, so bring that upstairs, make it to the negative 2. So y prime is equal to negative 2 times negative 4 is 8 times t plus 2 to the negative 3 times the derivative of the block. Well, that's just 1. I'll go ahead and write it. And that is 8 over t plus 2 all cubed. All right, so we're moving right along. We'll go to 26. Pause if you need to. Okay, we have f of x is equal to x times 3x minus 9 all cubed. So this is product rule and chain rule. So f prime of x is going to be the first x times the derivative of the second. So 3 times 3x minus 9, subtract 1 squared times the derivative of the block times 3. First times the derivative of the second plus the second 3x minus 9 cubed times the derivative of the first x. That's just 1. I won't write it. So that's going to be 9x times 3x minus 9 squared plus 3x minus 9 cubed. All right. Let's do number 30. I think I can fit it in here. 30, we have y is equal to x squared over the square root of x to the 9th plus 9. All right, a lot of 9's there. I'm going to rewrite this. If you want to go quotient rule, knock yourself out. I'm going to rewrite it as x squared times x to the 9th plus 9 to the minus 1/2. So we're going to use the product rule. The first, x squared times the derivative of the second, negative 1/2, times x to the 9th plus 9 to the negative 3/2. Subtract 1 from negative 1/2. First times the derivative of the second plus the second, x to the 9th plus 9 to the minus 1/2, times the derivative of the first, so times 2x. Now we just gotta, you got most of the points. Let's say this is a 5-point problem. Well, you just got at least 3 if you got that much. So let's clean it up. So we would have here, looks like the easiest thing to do. Oh, I messed up. Dadgummit. I forgot to multiply by the 9x to the 8th here. All right, so let me go through this one again. And it's good for me to forget to multiply by the derivative of the block, because that is probably the most common mistake on the entire test. Okay, so the first, x squared times x to the 9th, times negative 1/2, x to the 9th plus 9 to the minus 3/2. I forgot the block, so times 9x to the 8th. This is why I did this problem. Okay, the first times the derivative of the second, don't forget the block, plus the second, x to the 9th plus 9 to the negative 1/2, times the first derivative of the first, 2x. Now let's clean all this up. So on top I would have 9x to the 10th, x squared, x to the 8th. There is also a negative there because of that negative 1/2, over 2 times x to the 9th plus 9 to the 3/2 plus 2x over x to the 9th plus 9 to the 1/2. All right, you could put that as a radical if you want, but I am fine with this. You made the exponents positive, you consolidated the x to the 8th and the x to the 10th, and you brought that 9. This is good enough for me. Okay, so sorry about that mistake, but sometimes when I make a mistake and catch it, that's a good warning for you. I will tell you, forgetting to multiply by the derivative of the block is the biggest, most common mistake made on this test. All right, so me doing it probably will help cement that in your brain. Okay, let's look at number 32. Are we doing 32? No, we're going all the way to 44. Sorry about that. And we have y is equal to, now we're going to do several trig ones with chain rule, sine pi x. Okay, this is a 2-layer onion. So what makes it chain rule is that it's anything other than x here. So y prime is going to be cosine pi x. So cosine, so this is the block, cosine pi x times the derivative of the block, which would just be pi. So that's going to be, we need to bring that pi out front, pi cosine pi x. The reason I bring the pi out front is so you don't confuse it with the angle. All right, 46. We have h of x is equal to secant x squared. Again, because it's not just secant x, it's an x squared. That makes it a chain rule. So h prime of x is going to be secant of the block times tangent of the block, secant x squared tangent x squared, because the derivative of secant is secant tangent, times the derivative of the block 2x. So we'll just bring that 2x out front. All right, and there we go. Okay, we're going to get into a couple of 3-layer onions, so I'm going to erase, give myself a little more room. So this is number 48. And we have g of t is equal to 5 cosine squared pi t. Now here's what makes it a 3-layer onion, meaning you have to do the derivative 3 times. That's squared, and that it's not just t, it's something other than t. All right. I'm going to rewrite this in a way that's going to make it easier to take the derivative. 5 cosine pi t all squared. Because that's what that squared means between the two. You take that entire trig function and square it. So g prime of t is equal to 2 times 5 is 10 times cosine pi t. And then I'm going to go ahead and write the 1 this time just to illustrate it. So subtract 1. Then we're going to take the derivative of this first inner block. So that's going to be times negative sine pi t. So that's our second layer. And then we have the derivative of the angle, that third block, the innermost block. So that's going to be times pi. All right, so this, consolidating everything, we would have minus 10 pi cosine pi t sine pi t. All right, I think I can squeeze 50 in here, even though it's a 3-layer onion. So we have y is equal to 3x minus 5 cosine pi x all squared. Okay, what makes, now this part's just 3, right? What makes this a 3-layer onion? Well, the square does, and something other than x, all right? So I don't have to rewrite this. It's there like it needs to be. So y prime is equal to the derivative of 3x is just 3. All right, minus 5. The derivative of cosine is minus sine, right? So that's I'm going to go ahead and put the minus minus. 5 sine pi x squared. Okay, derivative of cosine is minus sine times, and let's go ahead and maybe do that. That'll probably help. Times 2 pi x, 2 times the pi x out front, and then to the first, times the derivative of pi x, the innermost block in the angle, and that is just pi. So it's going to be 3 plus, because minus minus, 5 times 2 is 10. We'd have pi squared x, right? Pi, 2 pi times pi is pi squared, x. So times the 5 and the 2, I bring all that out front, and then minus minus makes plus. What a mess. Sine pi x all squared. All right, so, you know, that's a toughie. It'd be easy to get lost in that one. You could have a 4-layer onion in real life, but I'm not going to give you any, okay? No 4-layer onions on the test. Okay, I think I got maybe 2 more to work. And this is, I realize these videos are pretty long, but if we were in class, it would be, I'd be working just about the whole class period. So we have y is equal to sine root x plus root sine x. Let's rewrite that as y is equal to sine x to the 1/2 plus sine x, the whole thing, to the 1/2. Now, each of these are chain rule, but they're not 3-layer onions. They're just 2-layer onions because we just have x there, and we just have x there, not something else. So y prime is equal to cosine x to the 1/2 times, okay, so think of it as this, right? 1/2 x to the minus 1/2 plus, and then treat this as its own entity, 1/2 times sine x to the minus 1/2 times the derivative of sine x, which is cosine x. So each one, even though this looks pretty complicated, each one was just a 2-layer onion. All right, so this would be cosine. I'm going to make it nice and take that x to the 1/2 and put it back under a radical, since that's prettier, over 2 root x, so bring that x to the negative 1/2 down, plus cosine x over 2 times the square root of sine x, all under the radical. Okay, so watch that one again if you need to. And let's finish this video up with doing a tangent line equation. (64). So we have y is equal to tangent x all squared, and we have the point pi over 4, 1, and we want to know the tangent line equation. Well, in order to get the tangent line equation, we have to take the derivative so we can get the slope. So that's going to be 2 times tangent x to the first power, which I normally wouldn't write, times the derivative of the block. Gosh, don't forget that. It's so easy to forget. Times secant squared x. So the slope, we're going to plug in the x value, pi over 4, into the derivative. Tangent pi over 4 times secant pi over 4 all squared. That's going to be the tangent of pi over 4. Remember, it's going to be root 2 over 2 over root 2 over 2, so tangent of pi over 4 is just 1. So you'll have your unit circle. The secant of pi over 4, well, cosine of pi over 4 is root 2 over 2, so secant would be 2 over root 2. Just flip it, but we have to square that. So that's 2 times 4 over 2, which is going to be 4. So that's our slope. So let's plug it in. Now y minus y1, that's 1, y minus 1, is equal to 4 times x minus pi over 4. And circle that and be happy. You finished the derivative section. Our next video will cover implicit differentiation and related rates. And I will talk to you then.